Hello! Today I wanted to talk about how I've been doing error handling in LabVIEW. So let's start by talking about an example. Here is a VI, a hierarchy of VIs that is supposed to validate some sequencing JSON. So if we take a look at an example sequence, this is a bunch of currently handwritten JSON that could have the potential for lots of structure issues, braces in the wrong spot, missing commas, extra braces, typos in the element names. There could be way more than one issue throughout this JSON file. And I've been working on this software stack called Volatus. It's most of, well, maybe not most at this point, but a lot of the other videos I've been posting lately have been about that application stack. The whole goal of that application stack has been to be able to put more and more configuration and ability for end users to create and modify test systems and control software without needing my involvement. So as this is being developed, there's lots of handwriting JSON files, handwriting IO configuration files. And if we follow the trained way of doing LabVIEW error handling, you'll get into the situation where as soon as you find an error, you stop running all of the rest of the logic and whatever thing you're trying to do because you pass the error wire through everything. Every sub VI is completely enclosed in error case structures, and they get told one thing is wrong. They fix that, and then they get told, they try to rerun it, reload it, they get told the next thing is wrong. They fix it, they try to rerun it, they get told the next thing is wrong. And that's a pretty bad user experience. Additionally, when we're programming the functionality behind all of this, it's really inconsistent error handling, error behavior. Well, it's not inconsistent because it is just, it does nothing once an error happens if you follow the way Core 1, Core 2 teaches you to do error handling. So instead, what we want to do is we want to have more consistency in how we react to errors, what parts of the code decide what to do when an error does happen, and we could be more purposeful about this. Now, anybody that's been paying attention to the sticky note in the upper right, Darren Nattinger has a fantastic presentation about Brainless LabVIEW programming. And so if you Google Brainless Programming LabVIEW, you'll probably find a couple of recorded presentations he's done, the forum post that has links to the PowerPoint and some other information. But there is not a thing he says in any of the sections about error handling that I disagree with. I think the trained way to do error handling in LabVIEW leads to laziness and not properly handling errors. It is an easy pattern to follow, and as his presentation title alludes to, it's brainless. We don't have to think about it. We can just do it, and we will understand how the program reacts. But then as soon as we need the program to react a different way, now we have to spend more time thinking about it because we've been trained to just assume that everything stops as soon as an error occurs. But that's also a terrible user experience. What if we want some networking code to send that error message to the GUI to say that an error occurred? If you're in the habit of just wrapping your send VI in an error case structure, and that you mistakenly, perhaps you intended to not wire that error wire in, or maybe you have automatic error handling turned on, so you by default are in the habit of wiring every error wire, which Darren also does talk about. So yeah, I highly recommend watching this presentation. It's great. I disagree with some of the later stuff because it introduces some maintainability issues, but by and large, this is a very good presentation to get you to start thinking more actively about how you're crafting your LabVIEW code. But anyway, lots of people are in the habit of wiring every single error wire, every single error terminal that might exist. So you could accidentally wire your error into your send VI, and your send VI isn't going to send the message that there was an error. and then you're going to do your cleanup code and whatever else your program might do. So I, instead, always do the behavior where running a VI, let me find an example one I want to look at. I'm just going to pick one randomly. No error case structure. If I call this sub-VI, it should do the thing that it is supposed to do. It should report if it has errors, and because we often use the error wire to force execution order of functionality, I do still pass an error in to an error out, but I want to add in the error for anything that might happen inside that sub-VI. I want to get that passed out as well. Now, if you don't want this functionality to happen, don't even call the sub-VI. The calling code, whatever calls this sub-VI, is the code that understands the relationship between whatever happened before calling this VI and what happens during this VI and after this VI. The calling code is what should be making the decisions about what happens with this. Let me see if I can find an example of that quickly. No, because my error handling, I don't know where I would keep something like that. So I don't have a good example of that in mind at the moment. But yeah, calling, it's minuscule, but calling VIs has overhead. So if we know we don't want that functionality to happen, why rely on calling the VI and that VI deciding itself to not do anything? We could just not call it, and that would be faster. Over individual calls, it's practically unmeasurable, but when you get really large configurable programs that might produce lots of errors because it's got lots of configuration files and user input, that could be a lot of opportunity to make the program more efficient and save CPU cycles so you can do more really big, impressive data handling stuff. So yeah, so I don't, in fact, when I make a new VI, so let me just make one as an example, I have edited the template to get rid of that from, get rid of the standard case structure in the new VI template. I think probably 1 out of every 400, 1 out of every 500 VIs I write, do I ever wrap the entire sub-VI in an error case structure. So it is faster for me to add it in than take it out. But for most cases, I would say, yes, it is faster to remove stuff than add stuff. Now, the other thing I wanted to talk about is how do we handle multiple errors? LabVIEW, if I write a little bit of quick code here, does have a built-in way of collecting and reporting multiple errors. We can right-click a merge error node and tell it to retain all errors. And then if we put that in an indicator, we'll see the code is the first one that was reported. So again, things higher up towards the top of a merge error take priority. And then the ones lower down come later. So this does track that there was an error that occurred. That makes this error wire still work with things like error case selectors and a handful of other things. The not you could use it as a conditional in a for loop or a while loop. So properly making sure that there is a code and status set properly is good. But what if I'm in a section of code that cared more about the error code on this second error that happened later? There are also multiple error VIs that are part of the VI lib. And you could do a whole bunch of stuff with this to combine errors into a single error, split them into arrays of errors, and then you could iterate over the array of errors, doing checks for, is this one the one I care about? Does this one have this specific error code? So it's possible to use this, but anytime any of this is being used, it's doing a whole bunch of JSON operations. Notice that what's in here is a JSON array of objects. So it's got to do a lot of string processing. Anytime a new error is added, anytime you try and do any checks on it, anytime you try and do anything other than look at just the status and the top level code, there's a lot of performance hit that comes with it. It's probably as optimized as it can be for JSON processing, but that's just a lot of string processing. Now, as the example I was talking about was, how can I write code that reports as many errors as possible about this JSON so that they can try and fix it all at once and then be ready to run the next time they try and run it. So I've got this VI here. The whole point of this is to generate errors if any of the sequence JSON is invalid. So instead of using that inefficient retain all errors, which produces JSON, I've started using this pattern where I've got a multi-errors class that can collect multiple errors for me. And then when I'm done collecting multiple errors, then it can turn it into a single error wire, but with a much more sane and human-readable error message, in addition to some extra context that I can add in. So let's take this example, put it in here and run it. And it validated it. It didn't find any errors. But now let me go start putting in, I need scroll bar. Let me go start breaking some stuff. I'm just going to put a couple of underscores in. And now I get this nice message that says there were 4 errors. And I get error codes for each of them. I do get a generic error code up top. It literally is generic error. It's the asterisks error. But I can get some nice digestible information in here. So here at the top level, so I've got some context. The name element was missing. In the states, the stop state, the steps times 0 commands, has a missing type element. The abort state isn't configured. So this has a lot of functionality for giving users of the software much more information. And if it's more helpful for the users, it's probably more helpful for me as well. One of the things I take issue with the standard LabVIEW error handling, even the single error handling, is a call chain is not necessarily helpful to end users. What I would like to provide to end users is context that is relevant to the thing they are responsible for managing, such as a sequence file that's going to have some hierarchy. So we can see that I can sequence. Hey, look, there's a sequence object. Can I collapse or expand all this at once? I don't know what the keyboard shortcut is. But we're going to go to states. States. Oh, I have an empty string. Okay, I've got a bug somewhere. It should say stop. I'll have to find out where that happened. But steps, commands. Oh, right. Did I accidentally? Is that one of the things I put an underscore in? Anyway, I made a bunch of changes to this. I forget why, where that would come in. But I can get better context about this. So let's look at this example. Sequence, states, stop, steps, times 0 commands. Steps, times 0 commands. And I had put an underscore at the end of this. So it's saying it doesn't have a type. So this is more useful for building up the actionable information for users and developers alike. Once you get this code tested, presumably the code works, and the thing that's going to have the issue is the dynamic input into the code. So it's not even helpful to have a call chain, which you could have arbitrarily nested sub-VI calls. Organization of the code isn't necessarily going to match the organization of the thing you're processing. So the call chain is generally just less helpful. So most of the time I ignore it. There is provisions in this to report the call chain, but most of the time that's not helpful. So how do I accomplish this? Well, as I said, I've got a multi-errors class. You can optionally pass in an upstream error, or you can, depending on how you want things prioritized and how you want it to combine. But then instead of having the error in and error out error clusters, I pass in this multi-errors class. Now, what would be nice is if there could be, maybe, I've thought about this, I don't know if I would like the performance hit of the dynamic dispatch for every call, but this could be some kind of error hierarchy where there is a generic base class for collecting and reporting errors, and then you could have different things that collect multiple errors, collect single errors, automatically put errors into a log file. But establish this pattern of having more dynamic error capabilities that still follow the same wiring paradigms that we're used to seeing for the most part, but do allow us to change the standard error behavior in a program. And this does you can mix and match code. So I've got the base configuration libraries was written well before I came up with this multi-errors class. So it can do stuff, and then if that does error, I can merge it in to this multi-errors object. So I don't have to go back and update existing code. I don't have to only use libraries that support multi-errors. This is something that can be added on top in the bits of code where I do care about reporting multiple things in a sane, performant way. So this looks for a bunch of stuff right at the beginning. Assuming it finds the thing that says that, yes, this is a sequence file, we can then start loading the sequence. So once again, I pass in those error classes, in and out that error class instead of the cluster. And now things will start to look a little funky. And that is because of the ability for this to maintain a context stack. So as we descend into these, I can start adding context to the errors that get reported. Now this might look a little confusing at first what's happening here, but anytime I've got this add context VI, the upper output has that added context to it, but then generally you're going to want to get back to the base context and remove any new context, not care about any new context that's been added once you reascend back out of sub-VI calls. So this is a pretty standard pattern with this mechanism. You're going to split the multi-error. Now, under the hood, this uses a, let me go to the class in the project. This sets up a queue to collect the errors. So this can be done in parallel code paths. It will enqueue up to a maximum limit, so it does default to a maximum size, so it can't just keep collecting errors forever and you run out of memory. So you can set that as big as you need it. It defaults to a fairly decent size, and it will even make it clear in the error reporting if it might have overflown errors and there might have been more errors that aren't being displayed. So it can do all sorts of fun stuff like that. But this bottom multi-error wire maintains the same context as what was passed into this add context VI. So this one that's straight through, this doesn't have that sequence added to it. Now we're not doing anything else with this wire, but once we pass this back out and we exit out of this load sequence sub-VI, we're not going to be in this context anymore. So we want to be able to pass out the error wire that doesn't have the sequence context added in. And if we look in the variables, we're adding variable context. If we look in the states, we're adding state context. For each state, we're adding whatever the name of that state is, and then further descending in. So when I pass back out of here, I don't care about, I'm no longer, any errors that would be added outside of the sub-VI no longer care about the states or the steps or the transitions. So this is a pretty common pattern. Now I do have this merge multi-errors. This works kind of similarly to the regular merge errors, but it basically makes sure there is a code and status set appropriately, but it does keep the context and everything from the straight in error and will effectively ignore the context stack from the upper error wire, but the output will be whatever the reported error is of either of those. But so yeah, so we can keep descending in, adding to that context stack. Now any errors we collect in here, again, we want to report errors from things that don't use this multi-errors mechanism. So there's a VI for adding that in. Anytime we collect an error, we're going to get its source, we're going to get its code, and we're going to build up a little cluster and queue that into that entries queue. Optionally collecting the call chain, which most of the time is false, but turning that context stack, keeping a copy of whatever that context stack was when the error was reported. So this does use potentially more memory, because it is keeping track of more information than the JSON was, particularly with the context. But it's doing a lot less processing along the way. So yeah, and then at the very end, when we're done collecting multiple errors, and then just another note before I do that is none of this functionality is blocked from there being an error. We run all of the logic to try and touch the entire configuration file as best as we can so that we can report all of the issues. So there's no full block diagram, error case structures anywhere in sight. When I realize there's a critical error that wouldn't let me descend any further in, I've got an error case structure in the calling code to not call the thing that wouldn't be able to do what it's supposed to do. Then at the very end, and there's a bunch of VIs to make it work more cleanly. Actually, did I forget to, let me find where one of those is. Find an instance of this. So a real common pattern is needing to select with a case structure based on whatever the last error was. And so there's this node to generate an error wire that you can use with an error case structure. And then this way you can have your error, you can have error code specific cases in the newer LabVIEWs. These do just report the most recent error that was collected, so we're always overriding whatever the last code was and the last status. So this is a change to the case structure behavior where what's in this error wire segment is the most recently reported error in this error wire path. So again, a little bit of a subtle change to how you would react to errors being reported and how they're propagated. But there's that available for using case structures. There's this guy to just collect just that last code into a normal error wire so that you can pass that into things that may care about errors existing or not. Or you want to do some execution order control, and the only thing that would really differentiate the execution order would be the error wire input. So there's a node for letting you do that very easily. But yeah, coming all the way back out, eventually we're done collecting multiple errors, and we want to get everything into a single error and then fall back into more normal error propagation and reporting. So there's this release VI. It can optionally merge in an upstream normal error cluster wire, but you're going to take in the multi-errors and generate a single error out. Now, the formatting for that is extensible. It does have a built-in default basic formatter, which dive in a couple of layers. It's got a default implementation. And then takes all of those errors that were collected in that queue and formats them into a nice digestible string. And that's where you can see it tell you that there might have been some lost, but it generates that generic error code, does say that there's errors in the status, but it builds up the status string in a much more readable format. If you wanted to do something different, you could implement this formatter yourself, which all you have to do is take in the array of errors, and there is an override VI where you get the errors. You get a flag telling you if it's the maximum number of errors that could have been collected. And then you get to choose how to build that into the error string. So you could build that into JSON, which would then be relatively easy to process later on in your code. You could, use the JSON text library from JDP Sciences, which is fantastic. You could build it into XML. You could build it into whatever you wanted your source string to contain in your error cluster. Now, this is the reason why there's so many layers, is because this just has to dive into this default format, but you would create a class that inherits from the multi-error formatter, override this format errors VI, and then just do whatever it is you want to do. I just split it out this way because of I wanted to do the access scope control for the default formatting behavior. But this is how I have now been accomplishing multi-errors. And again, you could generate errors that look basically the same as the built-in multi-error handling, but instead of doing the reprocessing of the JSON string every time it collects errors or you want to check errors, you can just collect errors along the way and then build the JSON string once at the end, doing that larger batch operation instead of a whole bunch of JSON processing along the way. And give your operators much better feedback so they can change. I think they can fix more things at once. So yeah, I'm curious if anybody else has any other insight to how they've been doing error handling that might be a little bit different from what's the standard error propagation and handling that's taught in Core 1, Core 2, and for the most part has been pretty standard from what I've seen. And curious what people think about this pattern of using classes to contain. I know classes are still a little bit of a contentious topic in the LabVIEW community, but having something that could be more extensible for error collection and reporting. So feel free to throw some comments down under the video, yell at me, agree with me, whatever the case is. I would love to hear from you. Thanks for watching.